Hello, my name is Leila and this is the hands-on tutorial section of week 1. So right now I have opened my MATLAB and basically you need to download and install SPM12, and after the installation you need to add the path to the MATLAB. So here is the location of my SPM folder. I click on it and here is the location that all the MATLAB files are located, and we need to add this folder, not this one. We need to add this one, the path of this one, to the MATLAB. So I do copy this address and I go here. This is home and this is set path. I click on it, I select add folder, I paste the address here and I see this SPM, so I need to add this folder. I click on select the folder and I have already done it, and then you click on save and close the window. After doing that, here in the command window you type SPM, you enter, and you will see this window. This is the SPM window, and in our POD we're going to work with fMRI data, so here I'm clicking on fMRI. Okay, now you have 3 windows. The green one is where we have our toolbox, and this one here is where you see the graphics, when you can see the brain image. And here actually you can see how the process is going on. And for now I want to take a look at our data, what data we're going to use. So here you have this file in the Moodle, and I extracted it, and here you have some files. You have 3 folders, so I'm gonna go into origin. So GH158, so this is a human, this is a subject, this is the subject that we acquire data from. This is like one person, one subject. I click on it, I have anat and bold, so this is related to anatomical image, and this is related to the functional data. So I click on anatomical image. I have one high resolution anatomical image here, and when I click this one I have exactly 128 bold images. I have 128 3D volume. So remember the slides, we got 3D volumes, the time associated with H was TR, so this is that one. So each of these is basically a 3D volume. And now I want to display one from bold images and the anatomical image. Let's display and see the difference. So here in the toolbox I click on display. I need the address, I copy the address. Oops. And yeah, I paste the address here, I can see it. I click on anatomical, I select this one and I check, okay, it's selected, and I click on done. And here it is. This is the anatomical image of the brain. You can see the resolution, you can see the voxel size. It's small, so the smaller it is, higher the resolution is. And also there are other properties here. And now I'm gonna display one bold image to see the difference. And it is, so as you can see, the resolution is lower, much lower, and the voxel size here is bigger, and all other information you may need later. So that was it. Now let us start doing what we have learned. So the first step after we have the data is to do slice timing correction. So here I have this toolbox and I have this option. I click on slice timing, this is the batch editor, and I have this module here. This is slice timing. So I need to actually introduce the data. What data I'm gonna do slice timing for. So I click on data. Here I click on new session just once, and a session will be created here. I click on session, and here I need to specify my images. So again, I entered the address, I click on bold, and I do right click, select all. It should be exactly 128, and I click done. It is done beautifully, and here I need to enter the number of slices of each 3D volume. From the data acquisition, we know that it is 40. So I enter 40. So this is not something that we need to calculate, we know it. We have prior knowledge. And TR here, TR is 2.4, and TA, what TA is, so it is usually calculated as TR minus TR divided by number of slices. You can see it here. So I click on specify, I wrote TR minus TR divided by number of slices. And the slice order, again from the data acquisition knowledge we have, it is top down. The slice order is top down, so I need to find it here. This is top down. This is the way we need to like write it down here. So again, I click on specify, and I enter the way I should. So yeah, I have number of slices 40. I need to write minus 2, and then 1, and then 39 minus 2, So here is the way that basically the slices, the 2D images of those 3D volumes, the slices are acquired. So because they have some effect on each other, each time it goes from here, top to down, it skips one. So let's say it starts at slice 40, it goes, the next slices get will be 38, not 39. It will be 38, and it then goes to 36. And when it goes to the bottom, it goes up again and starts at slice 39. It gets slice 39 and skips one, then it will be slice 37, and then it will be slice 35 to the end. So that is the reason why we write it like this. And the reference slice, okay, as you can see, also we can have the order here, 40, 38, 36 to slice number 2, and again it goes up and it gets slice 39, 37, 35, 33 to the end. And the next is the reference slice. So this is the one that we are going to somehow correct all other slices with it, and as I said, it will be the middle slice. So here we have 40 slices, so this one will be slice number 20, the middle. And here the images that are the bold images that are basically we did slice timing correction for are going to be saved with prefix A in the same folder. So now you can click on run, and after that you will see the files. I have done it before, so here in the same folder you can see the slice timing corrected bold images with prefix A, and they are exactly 128. So what is the next thing we need to do? So after slice timing correction, we needed to do realignment for those bold images that are corrected for slice timing. So here I click on realign, I select the estimate and reslice, again batch editor. So here we need to again specify the data, click on data, I click on new session, and here in the session I need to specify the data. I click on specify. Here I need to select those that are already corrected for slice timing to do the realignment for. So I copy the path, and here okay. In order to be able to find the ones that we want, in this area I type this. Okay, and now I type the prefix and .img, and then I click on enter. I don't have it here, why? Okay, I did it again, it worked, and right now I do right click here, and then I do select all, and exactly here I can see that I have 128 slice time corrected bold images, and then I click on done. Okay, And after this step, you can click on run, and this is gonna take a longer time. You click on run, and you will have your realigned, slice timing corrected images, basically slice timing corrected realigned images with prefix R. And is there anything else here to see? And that is all for this step. You click on run and wait to get your images, and you will see the process happening here. So right after you're done, you go to the same location. That's the bold data is there, and here were the slice timing corrected images with prefix A, and these were the data we had at the beginning, and right here. These are 128 realigned images. And there is also one more thing to see. Here we have this mean image. This is the mean of the all realigned data. And we are going to use this one for the next step, which is co-registration. So this was the one that we were going to align with the anatomical image of the subject, as I explained in the slices. Yeah, so we're going to use this and align it with the anatomical image in order to get the activation map of the brain. So here I click on co-register and I click on estimate and reslice. Here I have this estimate and reslice. So there is a fixed image, which is the anatomical image, and the moved image is the one that we want to align with anatomical image. So it is the mean image that we get from the previous step. I click on this and I'm going to give it this address, or not this one. I'm going to give it the address. I select the anatomical image and I'm done. Now I'm going to select the moved image. I go down to find the mean, it's here. This is the mean image we have, and that's it. Okay, so after defining the moved image, now we need to also define other images. The other images are those all that we have realigned earlier. So I click on it, I click on specify. Again, let's see if it works. Yeah. Now let's see what we have here. I need to select these with RA prefix. And here, I click on select all and click on done. I have exactly 128 files, and then and all these coregister file all these coregistered files will have the prefix R, so they will have 2 R's basically in the prefix. And so what exactly happened here? We had a fixed image, we had a moved image, and we had some other images, and these were the realigned images. So this is what basically happens. First, we are going to okay, so with this tree, basically this is what is happening. So first, the fixed image is the anatomical image, as I said, and then the moved image will be aligned to the fixed image, and from here the transformation is computed by using these two only, and after that the other images will be moved exactly the same way as the mean image, as the moved image. So this is basically what will happen inside SPM. And these files will have another R in their prefix, the coregistered files, and now you are ready to click on run. And this will also take a bit of time, and then you will have your coregistered images in the same folder. Now I come to my folder, and yeah, here they are. I have 128 co-registered files. And now let's display one of them. And it will be like this. So this was the pre-processing steps for the tutorial 1, and that was the end.